Yeah, hello again. Thanks for having me. I do like to, first off, second what Tim said. So ASPAS is a good thing, please do it. This will also be one of my major conclusions in the end of the talk. Having an ASPA or having ROAS is a good thing, but please also maintain those things. Signed things are signed, but maintained things and signed things are the thing we need. So please maintain and sign. That'd be awesome. So this talk is going to try to summarize a 1.5 years journey through the IRR landscape. These IRR databases are where the objects we have been talking about in this session quite a lot are stored in, and for historic reasons there are many different ones hosted all over the globe. And not all of them share the same status, and we initially had the observation that for at least those things that are like private organizations run, and not from the, we call them authoritative REERs operators, tend to maybe have some objects that look suspicious. Or basically anyone can enter some information there, and whatever the information is, if it's correct or not. And then we have also seen in the previous presentation BGP filter generation. So there are tools that crawl these external databases, these IRR databases, to generate BGP filters to configure their networks. That is done for security reasons, that is done to enforce some policies. And obviously the IXP DE-CIX, for example, also does that. So we have a tool chain in place that is this exact step that was presented in the previous presentation, that is the BGP filter generation. And from our handbook, it says something along the lines, it's paraphrased, but it says that the route server, which is basically our own BGP speaker that is free to be used by the peers, pulls in multiple external, in italic, I want to emphasize that it's outside of our control, basically, so I can't myself really do that much about it, but to analyze it and show you why there might be problems to that, and that is basically this whole endeavor that has been going on for a year and a bit, and checks each announcement per prefix origin AS and delegation. Okay, so that is basically what the filtering is all about. For this BGP filter generation, 3 different objects, RPSL objects, that are stored inside the IRR databases are especially crucial. That is the AS set. These are the, it's 4 actually, because route and route 6 objects, and the odd num for different steps. Those together are used to effectively configure what happens at the IXP's network, and probably, if you have some sort of BGP filter generation, also your network. So what happens now if you rely on this external information that you can't really do anything about, but to rely that it is accurate, timely, like not outdated, or not orphaned or even compromised, then this will end up in production. Incorrect filters, unintended black holes, redundant filters, or even traffic hijacks. Yeah, sorry, I guess that's a typo, that's on me. Maybe I'm hijacking. What? So, as said, there are lots of different databases around, and for our first investigation, we were differentiating between those that are operated by the official REERs, so we call them, or refer to them as authoritative, and then there are those that got founded in the times before the REERs were founded. So that's like the beginning of the 90s. We call them third party. They are basically self-governed, they can do whatever they decide to, and they can also they can't really figure out or enforce some certain quality, I would say, assurance for the objects that are being entered there. They have been better, much better, yes, but still from back in the times, and we will see that there's stuff around. Okay. So then, as you can see, this is also dating back to 2025. We, as an IXP, we've been to a RIPE meeting, submitted a presentation about a best common operation practice, like a BCOP, that we are proposing there, blindly saying, how about we just abandon all of these third-party databases for our, or for IXP filter, IXP-based BGP filter generation, basically everywhere. Just proposing this as a BCOP. Because it would have been much of a cut, there was a grace period for these 4, let's say, larger third-party IRR DBs to keep them for about 1 year and see what happens after that. The community was like, oh, are you serious? Is that really true what you're doing, what you're saying there? Can you really claim that the authoritative, great, so you've given them a majestic name and now they are better, are they? Tell us. That's what they basically said. And then they said, can't we just wait for RPKI? Because RPKI is enforcing some of at least clearances checks if there is an owner really behind this route object. Yes, only route object, not the odd nums and not the AS set. This is where ASPA is helping. Come maintain and create your ASPAs, please. And what about the legacy space? The legacy space is outside of the contract of the authoritative databases. So whatever, they won't have the objects. Just plain right away, they won't have it. Things can be moved for times, sometimes. We'll see the details in a bit. What did we do? We crawled the whole data from basically everywhere. We took, obviously, the 5 rears, their dumps, their objects, their RPSL objects, and 14 third-party databases. Lots of BGP data, also the RPKI data, threw everything into a big box, created a big pandas data frame, which got extremely ugly, but it's there. And also some other stuff that we needed for legacy. Handling legacy space is an absolute terrible nightmare, but we'll come to that. Especially about this legacy space, we were in contact with the rear operators because we want to figure out how can we tell in your database if that object belongs to legacy space or not, and we'll see different approaches. So first off, is the data in the authoritative databases better? What does better mean? So we were trying to come up with a method to quantify if they represent the intent of the operator more precisely than what is found in the third-party databases. And for that, we did a few things. First off, just a brief glance, where do these objects live? So what is basically the size, if you want, of the third-party databases and their objects? We're looking for the AS sets in orange and the route objects in blue, and you can see RouteB standing out right away. For TC, very interesting, they have tons of AS sets. And then on the other side, just as a comparison, this is what the size of the authoritative databases is. But yeah, we first thought update frequency. The internet is a living thing, so whenever there's a change, there are changes. It should be reflected in the databases as well. Fortunately, most of them use very consistently the field like last modified or changed, or there's even a third version of them and you have to match all of them. It's terrible. And this is what the plot looks like. So the orange part, once again, is the AS sets. That's not true. The authoritative database and the blue parts is the third-party ones. This plot basically tells you the object age in years, and the more it is shifted to the left, that means that there's a higher fraction of objects updated more frequently. So in an ideal world, all the information in there should be consistent and reflect what the reality is. So if there's an object 12 years old, then for 12 years we will not see an update there. But you can already see that the authoritative ones, these are the orange ones, are slightly to the left. So we can see, especially for the route objects, you can see that there is a tendency that if there are changes, they are more likely to be reflected in the authoritative ones compared to the third-party ones. TC, actually, as a third-party database, is doing a great job pushing that stuff. Like for the AS sets, that is basically all TC's updates. And yeah, for the route objects, looks, as I said, very differently. So that might indicate that changes in the internet are more timely reflected in the authoritative databases. For this plot, once again, we took all the route objects that we found and then quantified them by the size of the bubble, in which database they live. And then again, on the x-axis, if the route objects have the same origin then actually seen in the default free zone. So is the route object in coherence with what is in practice? And if it's not, we put them further to the right. And on the other axis, we see if they are even used or not. So yes, there might be route objects used for, as we have heard already, I think there was under DDoS attacks or something, for routing differently and used just on demand. So they just exist in a third-party database, but are not seen in DFC for good reasons. However, if it's orphaned, it is also in the same category. So we just use it as a metric. The more objects we found that have this attribute, the higher up the database is being plotted. TC, once again, hell yes. My shout out to these guys, very good work. However, for all the other third-party ones, they are clearly in the top right part, whereas all the authoritative ones are in the lower left. So this is like rather the good performance, and back up there is like bad performance. So even with the second metric, it tends to support our point that the authoritative databases have the have data that should possibly reflect the operator's intent a bit better. So that is basically our conclusion to the first point, having presented these two metrics. I'm very happy to have other metrics. Please propose if you have a good idea. I'm very happy to crunch the data again and see what happens, because I think there is a tendency. So why don't we just wait for RPKI and just abandon this whole route object hunting here? It is because not everything in there can be recovered by RPKI. I especially want to point out that about a million objects. All right, so this plot is very difficult. Let's go. What we have here is the red part where it's just conflicting with anything, like even with RPKI or whatever the authoritative databases might be saying, or the DFZ or whatever. Then we've got this yellow big bar, at least in RADB. I mean, this is like the very big one. We have to look in more depth. They are duplicate or irrelevant or not seen in DFZ, so like basically all of them you can take apart. This is like a million route objects that they have is just either conflicting or duplicate. Now let's talk about the relevant ones. And then the question is, can RPKI help with them? For all the other databases, it seems to have the same distribution, just as they host fewer objects, obviously the bars go down. And on the right, we have got the authoritative just as a reference here once again. This plot basically shows that these problematic objects are really routed, at least DE-CIX, and we also had joint work with IRR there. Thank you, Stavros, if you ever happen to watch this recording. Thanks for helping us here. And we do see that, yes, indeed, a multitude of tens of thousands of these objects that are problematic are still routed at our platform. Yeah, so we've got the numbers here to the right, but all I want to say is they do matter, they are there, and this is where RPKI might not necessarily do the trick here. These are still vulnerable and injectable objects regardless of their RPKI status because they're just not covered. And then last but not least, we've got the legacy space. And my boss likes to put this meme here because there are objects in third-party databases that cannot be moved to their authoritative counterpart. Why? Legacy space. That is a longer story. I think we spent about half a year of getting behind the idea of this legacy space distribution and where it is and how to identify it like in an automated fashion, because I don't go through this whole list by hand. Well, as I said, it's allocated in the time before the 5 years RIRs were established, and they do very different things about the legacy space in their area. We were basically calling them and saying, hey guys, how do you go about this? How can I tell by your data in your database if that's a legacy IP block or not? And from Afrinic, we basically didn't get a reply. They woke up actually, I think 2 weeks ago, which is great because we asked them a year ago. And I said, is this still hot? And we said, okay, sit down. I think the boat has departed. But whatever. What do they do about the legacy space? So this table is basically showing that if you have legacy space, you may or may not, depending on the region you're in, use the IRR service so you can create a route object. Okay, so legacy space can be moved in some cases. I want to point out that especially RN, notably the one that should host the most legacy space, seems to be problematic because they require a service agreement for just creating route objects. For RPKI access, it's like different with the other ones, all right. But this also requires to go through a due diligence process to really prove that this is your IP address space just to create a route object. And if you imagine that maybe in the 80s or so, IP address space located in RN was handed over on a napkin because some person just gave it to you, you might not pass this due diligence process to get a route object. So that is what we refer to as the problematic case. And we once again analyzed where is it now. By what we could tell, at least, as I said, Afrinic did not reply in time. APNIC we just didn't really care about because according to their reports, almost all the legacy space has already been returned to them, so they are actually under control. They have a contract of that, that's good. So we did not identify those two in the data. And then we're looking into the other 3 databases for which we can identify the legacy space, and then we also noted if it's movable, it would be movable or not. And exactly this movable thing or not is RN only, and this is what we plot there in the upper part, the green part, of which there is a need for a new service agreement. So the light green part is the RN legacy space, and the darker one is LACNIC or RIPE in turn. If we're zooming into those objects, legacy ones that cannot be moved, we find that, what is that plot about? I should have checked before. How many of them are actually used? Are they active? Are they inactive? And we see that yes, most of them still are active, so moving them would be a thing we want really to have. We also find, once again, orphaned objects, or apparently orphaned ones. Like they're not used in the DFC, they're not routed at DE-CIX and whatever. So what do we see here? Legacy space is a problem because of their RN procedures. It could be, in theory, be registered in some other rear, yes, but talk to people and get them to do something is like pretty hard. And mostly the legacy space hosted in RawDB is the one that belongs to RN. That's what we found. This whole story until this point was, or is, also concluded in 2 RIPE Labs articles that I co-authored, a team of 5 persons behind that. There will be a third part that we are currently working on. Yesterday I did some crunching there, still looking into stuff. And we would now differentiate between just dropping all the third-party databases and only dropping certain object types. So if we say we're not looking into AS sets from third-party databases then, but still generate the BGP filters based on whatever route object, wherever they're from, what would happen? We're also looking into ROA, so RPKI ROAs, derived fake Route 6 objects. So if we allow for them again, what would happen? We're going to look into the prefixes that would be lost, I mean, at the route server. Yeah, this is like the basis of data that we can use. And then we're going to measure what would that mean for the actual production traffic on the platform. So that is going to be part of the RIPE Labs article number 3. So we do no longer pursue the idea of just dropping all the databases at the same time, but we're going to look into what happens if we abandon certain type of objects in terms of what does it mean for the traffic. Then we're also going to look into where are these prefixes. Because as said, this is a RIPE BCOP proposed for the RIPE region, or we would be proposed it for the RIPE region. And if then most of the prefixes lost are in the US, well, most of the RIPE region-based IXPs, they might not necessarily care because maybe they don't have the ARIN-based prefixes, which are probably the ones that would be lost. And for getting the data, all of this, we have a test lab set up. As said, we're looking into deprecating different types of objects. So I have different, we call these things scenarios, in which we take different decisions. And by them, I configure the IRRD. We're running IRRD for storing all the RPSL objects. And then we've got the route server toolchain that from this database pulls all it needs to generate the config for our route server, and then this is put into a route server lab. It's like a virtual session with 1,000 simulated peers and our simulated route server with the per use case or per scenario specifically configured config. And this helps us to basically pull the exact, hopefully as close as possible, but I call it exact, scenario, all the prefixes that would be lost in that case. And from there we go with the traffic analysis, which is yet to be done. And I'm yet to debug this because it's no good. But all over and together, I would say, yeah, there's going to be a third part, as I said, for RIPE Labs articles that is going to measure the traffic loss. And we're looking into different scenarios. All the details are going to be there. I can give some spoilers here, and this is where I think I draw a big circle here from the very beginning to the end. Maintain stuff, sign your objects, create ASPAs, and maintain them. That would be a good replacement for what we rely on in the third-party databases in terms of AS sets. And as of now, it currently seems that actually, yes, instead of looking up third-party route objects or third-party IRRDB hosted route objects for the filter generation, that RPKI is actually doing a pretty good job getting those objects back, like just replacing it practically. So yeah, with that I'd like to conclude, and thank you for joining me on this journey by deprecating old messy IRR data and replacing it with the cryptography signed RPKI system that we are building. Thank you.
Thank you very much. Do we have questions? No, we don't? Okay, in that case, thank you again.
Not even you've got a question.
Okay, fine, I will shoot.
I'm at the sauna and at dinner, so I can...
That's the standing question, fine. So if you do have questions, you're just not asking them now. You can find him in the sauna. But my question is that there is a little bit of a semantic difference between RPKI and IRR when it comes to route objects, right?
Yeah.
So one is signed by one party, the other should be signed by both. Do you see benefits, or are we going to lose something because of only one signature?
So the ROAS, the route objects, sometimes when they are in a third-party database, they can be just absolute trash. So I can, if I go to NTT, sorry, I'm not supposed to say names. If I go somewhere to some database, I can enter something that would not be possible that easily with RPKI or ROAS signed RPKI ROAS. Still, yes. Is it a semantic correct replacement? Will it fix the internet? Probably not, but I think it puts a big second hurdle for an attacker to inject some random stuff that is necessary for them to carry out an attack. So at least for these cases, I think we're on a much better side than from before, and especially hopefully, I have seen a RIPE talk on this, I think it was like 2 weeks ago or 3, about 21% of all cryptographically signed RPKI ROAS point to an AS number that is no longer in use. So that's why I said, please maintain your stuff. So having it signed is one half of the story, but please maintain it. And yes, if we now refer to them and there's like also orphaned or outdated but signed information, it's no help, but please maintain. You could also maintain the IRR data and then we don't need RPKI, but still like it is adopted very broadly and does not have this legacy mess from the 80s.
At least the signatures on the ROAS and RPKI do time out after a while, and you have to reconfirm that this is still something that I think should be true.
That's right.
There's some kind of a self-correction in that.
There are some other mechanisms in place that the IRR system just doesn't have. And altogether, I think it is a viable option to go with.
Yes.
Again, so about what you might call still ROA configurations in our interface, there's quite a few of them. So the RIPE-NCC RPKI dashboard really guides you into looking at your own announcements and making sure that you make the announcements valid that you believe should be valid. It does not an equally good job when it comes to telling you that you have ROAS that may no longer be needed. And this is something that we'd like to look at as well in the future.
It would also help
that, because I think what happens a lot is that when people make changes, they do a new announcement, then they add the configuration for that, so the ROA gets created, but it's not cleaned up. And this can actually lead to problems.
Yeah.
Okay, going once, going twice. No more questions. Thank you.
You're welcome.